Now this is a function that's very interesting because of its behavior near x equals 0. Just look at how dense the graph becomes. We have f of x equals 1 cosine of 1 over x on the left side. You see the green circle there. If I zoom in, you'll see that this thing that looks like a thick or something with area does not have area. In fact, it's just a bunch of lines getting closer and closer to each other, which kind of gives this impression that this is a filled-in picture. In reality, that's just a bunch of lines, right? So what do we know about this function? Cosine of any angle is between -1 and 1. So you can see that in the graph. No y-coordinate is above 1 or below -1. However, we have a problem there. If we get closer to 0, you can see that the cosine of 1 over x is not defined at x equals 0. So if we try to understand what happens when x approaches 0, you'd look at the t value, and the last item on the left sidebar that you see is f of t. So for example, f of 0.45 is the cosine of 1 over 0.45, which is negative 0.61. We're being told that. So I'll make t get closer and closer to 0. You're going to see point A approach the graph, show up. You already see how fast it oscillates. Let me play so we can follow A maybe and see what happens to it. It's going to come back now. See, it's already gone. So let me go back and see if I can get some values that are more interesting. See if I can change the increment. And maybe in the thousands, we're going to have more luck. Let's see. Still too fast. But this is the idea. I see. I know what I'll do. I'll decrease the size of the interval. So I'll only allow t to be between -1 and 1. Maybe even less than that. Let's go 0.5 and 0.5 because we're interested only in the t values that are close to 1. So that's going to go slower, right? There you go. So as we approach, look at what happens to A. Point A varies so quickly, and the closer I get, the quicker it changes. So a point that's very close, like 0.07, has a -15 that's close to 0, a value on the left there. But then if I go closer, I get a negative value. Very negative, in fact. And you can see that the y values vary widely between 1 and -1. And you always have the undefined value at t equals 0 that you can't calculate. So this is an example of a function that does not have a limit when x approaches 0. And it does not have a one-sided limit, neither a left side limit or a right side limit either, because this phenomenon of oscillation between -1 and 1 happens on both sides. Keep this function in mind. This is an important example.